Good morning, students. In today's class, we'll be doing methods to prepare benzene. The first method to prepare benzene is from acetylene. Acetylene is the other way of calling ethyne. That's the common name. The ethyne molecule, when you pass it through red hot iron tube, red hot is the temperature and iron is the catalyst in this, leads to formation of benzene. This benzene can only be formed if three such molecules undergo a polymerization reaction known as cyclic trimerization. Let me explain the process. Three molecules of acetylene. 1, 2, 3. These three molecules undergo cyclic trimerization. The pi bond breaks and forms a bond here. This pi bond breaks and forms a bond here. This pi bond breaks and forms a bond here. If this happens, then you are left with the CH identities where this CH identity has got two bonds, one bond here, again two bonds, one bond here, again two bonds, one bond here. Hence you end up in alternate single and double bonds, which is your structure for benzene. The process is called cyclic trimerization of acetylene, where three molecules undergo a reaction of cyclization leading to the formation of benzene. The second method of preparation is from phenol. The structure of phenol is an OH on the benzene. This phenol molecule has to be transformed into benzene, which means there has to be a loss of OH. That's wrong. It is not an OH. It is only oxygen. Because by the removal of oxygen, you are still left with an H which you require to be placed at that particular carbon. Hence, we use zinc as the metal, which has a strong affinity for oxygen to remove the oxygen, and we use it at a temperature to just fasten the reaction. And zinc is used in the form of dust. When you have something in the form of dust or a powder form, it increases its surface area and reactivity. That is the only cause of using a reactant in the form of a dust. Hence, phenol can be converted into benzene by reacting with zinc dust at a high temperature. There is no need to remember the temperature, leading to benzene, and the byproduct is zinc oxide. The third method of preparation is from sodium benzoate. What do I mean by this? It is same as a sodium salt of benzoic acid. What is a benzoic acid? A benzoic acid is this. If I need a sodium salt, I need to react it with NaOH. It will lead to the formation of sodium benzoate. Of course, the byproduct would be water, which we are not interested in, but would definitely lead to the formation of sodium benzoate. Now, our starting material becomes sodium benzoate to form benzene. To the sodium benzoate, you need to add a reagent known as soda lime. This is nothing to do with the drink. It is sodium hydroxide in the presence of calcium oxide heating. This mixture of the two is called as soda lime. Calcium oxide merely maintains an anhydrous medium. The byproduct formed in this case is sodium carbonate. Have a look. Where do I get the sodium carbonate from? Na2C 1, 2, 3. Sorry, 1, 2, 3. So you have Na2CO3. You are left with the CaO is not reacting. Na2CO3 is the byproduct, and you are left with an H here. And this is the H that you require for benzene. So you get a benzene from sodium benzoate by the removal of CO2. The process is called as decarboxylation. Removal of CO2. The reagent used is soda lime. The last method to prepare benzene is from N-hexane. 1, 2, 3, 4, 5 and 6. A normal hexane can be transformed into a benzene ring. This process is called as aromatization. It is also known as reforming. It requires special conditions of temperature, pressure and catalyst. The catalyst can be vanadium pentoxide, chromium trioxide, molybdenum trioxide. Any one of them can be used. This compound actually is C6H14 and you are transforming it to a C6H6. That means loss of 8 hydrogen atoms or loss of 4 hydrogen molecules, which is caused as aromatization is the reaction. There are steps to it, but as of now, the first step required would be to cyclize it, and the second step is for the pi bond formation, that is eliminating the 3 more hydrogens after the first hydrogen molecule. Before I end, in case the starting material is a N-heptane, you would have 7 carbons. Under the same set of conditions, aromatization is only applicable to benzene formation. That would use up your 6 carbons. 1 carbon left would be your methyl ring. Hence, you will not end up in benzene but in toluene. The rest of the process remains same. This also falls under the same category of aromatization or reforming. The conditions remain same. 773 Kelvin the temperature, 10 to 20 atmosphere the pressure, and the catalyst can be any one of them. Thank you.